Oh wow, this project is called Neurocities and Ruinscapes. It is basically a marriage. This sounds so crazy on paper. It's basically a marriage between neuroscience of eye movements married to the concept of exploring ruins and archaeological sites. Can we track what people are looking at for how long? That's the neuroscience side of it, the neuroscience of eye movements. And can we use the information so that you can say something about the ancient mind? You really want to see how people are going to interact and explore with these environments. And one of the ways to track that is via eye movements. With the data we worked with, which was the Etruscan statue in Italy, people actually go to this museum, they stand in place and they start looking at it with the people eyeglasses, recording their eye movements. It has an outer camera and then two inner cameras here. These two are locating the pupil positions as X and Y coordinates, and then this outer camera is tracking the scene of what you're seeing. So all this data has been captured, but the problem is, okay, it's an XY coordinate, but where exactly in the frame of this video is the person looking at? I could have been looking at this direction, and there's an XY coordinate in this direction. But now if I switch to this perspective, the XY coordinate here doesn't mean the same thing as the XY coordinate over here. There was a change in perspective. There was a change in frame. We actually needed to go through the video, pick out a really good frame of the video, and say this is our reference frame, and then we plot the gaze points on that reference image. The frame that wins out and becomes the reference frame is basically the frame of the video that is most similar to other frames in the video. And then the other question was, how do you choose the best frame per video, but then do that for 40-something videos? Same thing. Across these 40 best contenders, you choose the one that is most similar to all the others. You have a reference frame. As you move on through the frames in the video, the X and Y coordinates are essentially pointing to different frames than the reference frame. So then how do you account for changes in scale, changes in rotation, changes in translation, meaning left or right? And that, we spent time on that. It was basically, it's image shifting algorithms. This is a reference frame. The person, this is the new frame, like that. And then the person looked specifically at this spot. Then the algorithm does a series of transformations to then say, reference frame. The gaze, after the transformations, we know the location of the gaze point on the reference image, so then we say, boom, this is where the person looked at. Once we solved that problem of where people were looking at, then we start getting into the important question of, oh, what if there's a necklace here? Like, what do we call that necklace? What if it has a specific name? Like, we wouldn't know. We don't have domain knowledge. So then the exciting part was saying, what if we leave that up to the user? We give them that reference image that we generated in the previous step, and then the user draws a box. And then any gaze point that falls within those boxes that the user himself or herself tagged acquires that label. When we process the data, then that point at that specific coordinate at that specific point in time will have the tag. And that tagging process is what allows us to actually generate meaningful descriptive statistics of how long people looked at something, what did they look at, which is what the tagging is doing. So then after progressing through that stage, we jump into data analysis where now that we know what people looked at, what can we conclusively say about the data that we were given? We've learned a lot about the statue. What are we now learning about the participants? And the cool part is that because the tagging is just a series of boxes or rectangles that the user draws and then labels, it doesn't necessarily have to be a statue anymore that we're working with or a vase. It could be anything.